Well, thank you very much, Ida, and a very good evening, good afternoon, good morning, namaste and konbanwa. I'm delighted to be here in this global event, and it's so heartening to hear these young scientists sharing their work. For me, I'm going to more talk about the applications of the Earth observations for disaster risk reduction. So it's not about building CubeSats or hardcore space technology, but rather the use of space technology for disaster risk reduction. So my presentation today is I'm going to start with a slide of my organization first, and then followed by that, I would like to then talk about the disasters in the Hindu Kush Himalayan region, and followed by that, the challenges and opportunities that are there. In specific, I would like to share with you the satellite rainfall estimates that we use and its applications. And for that, I will provide you with some of the examples in terms of innovation in technologies for looking at flood forecasting, early warning, and give you some examples of the models that are running, and then provide you with just a summary or my conclusions. Yes. So I am from ICIMOD, that's the International Center for Integrated Mountain Development. We are located in Kathmandu in Nepal, and it's a regional mountain knowledge, learning, and enabling center. And primarily we are working for the sustainable development of the mountain regions of the 8 countries. So when we say 8 countries, it's Afghanistan, it's Bangladesh, Bhutan, China, India, Myanmar, Nepal, and Pakistan. So we are a regional intergovernmental organization working in all these 8 countries. Now, in terms of the Hindu Kush Himalayan region, you may wonder where this region is, right? So this region, the Hindu Kush Himalayan region, extends about 3,500 kilometers from west to east, covering all those 8 countries that I just mentioned. And then this region is a global asset in terms of food, in terms of energy, water, carbon, and cultural and biological diversity. Now, this region is also, from this region originates 10 major river basins, mainly the Indus, the Ganges, the Brahmaputra, that feeds more than 1 billion people in the region. So it's a large population that you are looking at, right? And so, like I mentioned here, immediately living in the region, we have 240 million, but downstream, nearly 2 billion actually. So it's quite a large area with extreme diversity and a lot of opportunities. Now, my organization, we are primarily looking at linking science to policy and practice. So we are kind of an interface between the scientific partners, the implementation policy partners, and then looking at bringing the basic science, applied science, and converting that into more knowledge and sharing that knowledge primarily for influencing policy as well as practice on the ground. Now, let's talk about the disasters in the HKH region. Now, you all must be right now hearing about a lot of floods and landslides that's happening in our region. If you turn on your TV, the first thing you're seeing is probably how Delhi and many parts of India are right now reeling in floods and flood disasters. So when you're looking at the various typologies of disasters in the region, floods alone account for more than 40% of all the disasters that are happening. In terms of people killed, it's still substantial. And in terms of the losses, it's more than half of all the losses is accounted by floods alone. And what's alarming is that more than 1 billion people are at risk of exposure to increasing intensity and frequency of these natural hazards. And this particular slide I put in here just to emphasize that these floods are not alone happening in small places. It's more transboundary. That is, it's being shared across different countries. The risks and vulnerabilities are shared across both borders for which data and information is required for timely early warning and sharing. So I'll give you some examples of some of the recent events that occurred in our region on the disasters. So one disaster that occurred now, this is again in India, that was in 2021 in March, where a large rock slide in very high elevations, about 5,000 plus meters, initiated a big rock slide, and a landslide happened, followed by that a big flood happened, which propagated downstream. As a result of that, it came, of course, by surprise, which killed more than 150 people, but also took away some recently, developed projects, hydropower projects. So that was a large, not only human losses, but also economic losses. So the loss and damage was extremely large. But what you can see from the slide is, these areas are very difficult to really go to. Access is, extremely difficult, particularly during such kind of disaster events. So the satellite images that were made available during that time were able to really look at and diagnose the problem, what happened, how. All these were possible only by looking at these satellite images that you can see on the slide here, one of the images, right? Now, the next one I want to share with you is one disaster that occurred again in 2021, and this occurred in Nepal. That's the Melamchi watershed that occurred here. And this was a glacial lake outburst flood, again in very, very remote areas, high up 5,000 plus meters in elevation, and which resulted in a number of landslides, followed by that a lot of debris, and then really affected some of the largest water supply project that was supposed to bring water into Kathmandu Valley, and a lot of debris deposition in the downstream. Fortunately, there was some kind of an early warning by people living in the downstream to upstream to the downstream. So people were able to evacuate with very minimal lives lost. But again, there was huge infrastructure damage. But again, the cause of this disaster was also, immediately to look into why such a disaster happened. Was possible to look at through some of these images, the remote sensing images that were available during that time. Now, so these are some of the images that were available that my colleagues at my office looked into and analyzed to see what the problem was. And with looking at these satellite images, we were in particular, possible for us to see that it was a small lake in the upstream that burst its banks, followed by that a number of landslides, and this big disaster that you see on your left-hand side, the huge inundation that occurred in the downstream. Yeah, so some of these applications are here that I show you. And then what I want to hear, I know we're talking about, of course, women leadership, and we are looking at how to really promote that, but we also have to see that during such kind of disasters, it's the women and the children who are the most vulnerable. So yes, while we talk about encouraging women in space technology, it's also urgently important to look at the vulnerabilities of women on the ground and how space technology that we are using could support reducing their vulnerabilities. So some of the key issues from such kind of flood disasters in the past, what does it really point out to? One is that we have very few observing networks, and data assimilation is very limited. Processing techniques and technologies to provide quality service products is limited. So thus, the amount of data, that is the in situ data, we call it. When I say in situ, it's observed data on the ground, like climate stations, for instance, like hydrometeorological stations. Those are very limited. And then not only limited, but also limited in terms of sharing of data information. The institutional capacity in terms of using these information, as well as communication and dissemination for floods, is very limited. I'm glad to learn that, that Antariksh Pratishthan is now also looking at piloting a project with Kitsune in terms of flood early warning in Melamchi. I would be eager to also a little bit understand, as well as know details of what that is, so that it can also be used and see how that can be used with other kinds of services that are available in Malamchi. And then so much of what is being done is, basically that we need to look at how we tailor the climate services for actionable response on the ground, and how we bring, women upfront in terms of making it more gender responsive and impact-based. So when we look at the opportunities, there's, different sectors. We're not only talking about one sector when you talk about application of space technologies. We're talking about agriculture and food security. There's weather and climate services, which I'm particularly focusing on, water-related disasters, which is linked with weather and climate services, land use, land cover, and ecosystem services. Also, air quality is also becoming increasingly more important. So all this here, when I talk about this, we see that the harmonization of climate data and information is very limited in our region. So that provides an opportunity in terms of how we look at risk assessments, how we look at harmonizing this data. And also there is greater demand from various organizations and for these such kind of services, and also opportunity for building capacity of our partners at different levels in terms of use of Earth observations to address these challenges and to improve the adaptive capacity to climate resilience. And then and basically ICIMOD being a mountain-focused organization, also we are looking at mountain-specific, information, mountain-specific products in order to address these challenges. Now, from this kind of overview of some of the disasters, I just wanted to then draw your attention to, so what do we need to do? So in order to really look at reducing these risks from disasters, we need to have these three elements: better understanding of the hazards, the climate, the weather, the event, the vulnerabilities, and the exposure, for which it is required that we increase our knowledge, increase our partnerships in different ways, looking at gender mainstreaming and governance, and using space technology, science and technology, looking at how we also bring in finance. That's very much important. The investment is extremely important to bring in, and improving the resilience. So in order to do that, I'll give you some examples of what we've been also doing at ICIMOD. One important aspect is cryosphere monitoring. We're looking at water availability, we're looking at hazards, we're talking about climate change. One of the impacts of climate change is right on the cryosphere, where the glacial lakes and glacial lakes outburst floods are of particular importance in the mountains, the high mountain areas. So ICIMOD has been looking at working on various inventorying the glacial lake outburst floods, also the glaciers, detecting the change over the decades in terms of what percentage has changed. And also we're looking at monitoring of these. So for this, we're using various types of satellite images and working on this on a regular basis. Another example, this is the same example, as well as doing some modeling using various hydrological and hydrodynamic modeling to see what the impacts of these bursts would be downstream. So another example I want to give you is in terms of using it for like you heard, the end-to-end flood early warning system. So when I say end-to-end flood early warning system, it's important that the first point of entry would be the data collection. So data collection, like I mentioned earlier, in situ data is very limited. So satellite-based information is critical then to fill in the data gaps that exist. So collecting this data and then transmitting it by different means, by satellite, iridium, or various other ways, GPRS, GSM technology, the mobile technology becomes very critical. And then using ICT and mobile to provide that information down to the users, those that are actually using this information have to get so that action can take on the ground. So this is another example that we are applying again, some of the satellite-based products in order to come up with a model. It's a regional model for the Ganges and the Brahmaputra basin. It's a mathematical model, but the data that is as provided as inputs are satellite-based rainfall estimates, as well as numerical weather predictions, as well as various global forecast models from these various types of data from various satellites. So this is example of how we are doing the forecast of the outlook of the floods 3 days in advance. We're using the hindcast for the hindcast, the observed real-time data, as well as the data from the GPM satellites and from NASA as well as JAXA, and then using it with data assimilation and using the forecast information from various models in order to provide the 3-day outlooks. So here I just wanted to show you a few slides which shows some of the satellite-based precipitations that we are using. The one that I just mentioned is the ICIMOD data set from NASA, as well as it's a constellation of satellites actually, NASA as well as JAXA and various other space agencies. ICIMOD stands for Integrated Multi-Satellite Retrievals, and it's a spatial resolution of 0.1 by 0.1 degrees. That's 10 kilometers by 10 kilometers. Very good temporal resolution of 30 minutes, and it covers quite a big domain. And then you can get more information from that link provided. Another example, this is again the GS map, the global precipitation map from JAXA. This is very good in terms of the rainfall watch. This image here you can see is the lot of rainfall that you can see in the area of Delhi. And this is just from today, actually. How much of rain is falling. So it's a good way of monitoring and using this, and you can find what is happening and monitoring of this. So the question again, I have explained it already, but why satellite-based precipitation? So it's primarily because, of course, the weak satellite density of rain gauges that we have. It's, when you use this satellite-based precipitation, it has high spatial resolution. So it's not a point data like a particular gauge. It has a very wide coverage and available in very remote areas too. So this provides a good opportunity for understanding what's happening. Plus, on transboundary basins that are sensitive, shared across borders, data becomes difficult to share. So then this provides an opportunity as well as opportunity for filling in the data gaps. So, straight using the satellite-based rainfall estimates without validation is not much of use. You need to validate this information and try to see how it matches with the observed data sets. And then you can use this information for those various purposes that I just described. Yeah, another example that I wanted to give you is this HiWatt. This is the high impact weather assessment tool that ICIMOD has developed for, again, flood early warning. It provides a 54-hour lead time forecast. It provides various parameters, temperature, rainfall, lightning, that you can get from this particular model. And another example is, again, this for more bigger streams, the stream flow, again, using the rainfall estimates and various numerical weather predictions to come up with this, which is then used. So you might ask, so what if this is available? Who's using it? Yeah, that might be a good question. So this is being used by various partners, various countries to support their flood forecasting capabilities and provide that early warning. So in summary, what are those key messages that then we have? Yes, one is that the technology and innovation is critical, particularly using Earth observations when it comes to monitoring of risks in inaccessible areas. The examples of which I already gave in Chamoli in India, in Melamchi. Yeah, so in situ and satellite merged products. So it's both the in situ data, rainfall data, as well as the satellite based. You're merging those products, you come up with a more robust data set, and then filling in the gaps to understand what's happening for the entire water and energy cycle, improve our forecasts, improve our understanding of what's happening in the extreme events, and then use it for different purposes like early warning. And then, of course, I mentioned about improving the climate services by the countries in terms of the provision of more credible data and information using these. And then one last point that I wanted to really emphasize, because I think it is possible that we have to work collectively. So for which regional cooperation and collaboration and partnerships is essential. And so co-learning, as well as sharing of data and information becomes critical, and in particular to enhance the resilience of the mountain people and to promote sustainable development. And space technology plays a very important role in all this. And I think it's very wonderful to be here at this particular event today to promote young scientists, youth. And I couldn't really resist when Ira contacted me to provide a presentation, because I am very, very, I just like to talk to youth because they are an inspiration for me. Thank you very much. Over to you, Ira.
Thank you.